When the facts bend reality, this is beyond plausible.
66 million years ago, a fiery asteroid collided with our prehistoric planet. When this massive object crashed into Earth, it caused one of the most catastrophic events in our planet's history. Known as the Cretaceous-Paleogene Extinction Event, or the KPG event. This extinction event rapidly devastated Earth's biosphere and wiped out about 75% of all species, including all non-avian dinosaurs. Giant reptiles like Tyrannosaurus rex never appeared on Earth again. These rare events also served as the key to starting a new era dominated by modern life. The Cretaceous-Paleogene extinction marks the boundary between the Cretaceous period and the Paleogene period, the first period of the Cenozoic era. It can be said that the Paleogene began with a difficult start. The asteroid impact that wiped out the dinosaurs triggered an ecological domino effect, disrupting Earth's ecosystems. Disasters such as tsunamis and wildfires raged across coastlines and forests. Fine dust and debris ejected into the atmosphere engulfed much of our planet in darkness. Photosynthetic plants that rely on sunlight for energy died, and many of the world's richest ecosystems collapsed. Herbivores and carnivores alike struggled to survive in this turbulent and dangerous world. Pterosaurs, marine reptiles, and non-avian dinosaurs were among the many species unable to adapt during this dark and cold chapter of Earth's history. Soon, as the dust and darkness cleared, the most extreme impacts gave way to a warming period. The greenhouse period caused by volcanic activity continued into the era, raising global temperatures and creating a more tropical climate, especially around the equator. This warming period triggered significant ecological changes as new species began to dominate globally. During the Cretaceous, some common plants were gymnosperms, which were early coniferous trees. Over millions of years, gymnosperms thrived in vast prehistoric forests and murky swamp areas, forming dense yet open ecosystems where reptiles and amphibians flourished. These similar plants struggled to adapt to the harsher conditions following the Cretaceous-Paleogene extinction event. As gymnosperms declined, angiosperms, or flowering plants, filled the niches they left behind. These fast-growing plants persisted due to important new evolutionary adaptations like flowers and fruits, attracting pollinators of all shapes and sizes. As flowering plants became abundant and diverse, they formed complex, jungle-like canopies known as tropical forests. These tropical ecosystems developed mainly around the equator in South America, Southeast Asia, and parts of present-day Africa. Within tropical forests, diverse plants and animals created unique ecological communities. To this day, tropical forests remain one of the richest and most biodiverse ecosystems in the world, hosting about 50% to 75% of all species. Just as flowering plants replaced gymnosperms, non-avian dinosaurs were largely replaced by new mammalian species, which began to dominate terrestrial ecosystems. The first true mammals actually appeared millions of years earlier, but during the Paleogene, they evolved and diversified like never before. Unlike many large and specialized dinosaurs, early mammals were smaller and more agile. Many, like early marsupials, could easily adjust their diets and habitats, allowing them to survive during this period of ecological chaos. When the final dust settled, small mammals were among the most resilient creatures remaining on Earth. These resourceful survivors thrived in the world's growing tropical jungles and facilitated the spread of flowering plants by pollinating flowers and dispersing seeds. Over time, Mammals not only increased in number but also adapted to various diets, along with different sizes and body types. Some became insectivores, feeding on numerous tropical insect species. Others adapted to plant-based diets, such as eating leaves, flowers, and fruits. Food webs gradually stabilized within and beyond the tropics. By this time, some important lineages had formed, such as the first ungulates. Primitive ungulates, surviving and thriving after the Cretaceous-Paleogene extinction, benefited from improvements in digestion like specialized teeth for grinding and chewing plants. Ungulates became herbivores, and some other mammals became the primary predators in many ecosystems. Relatives of modern dogs, cats, and bears, known as carnivorans, appeared during the Paleogene about 60 million years ago. The earliest ones were likely small, diverse predators, but over time they developed larger bodies, sharper teeth, and specialized claws for grasping and tearing meat. These carnivores largely succeeded because the giant predatory dinosaurs had disappeared. If giant reptiles like T-Rex had still existed on Earth, lineages like dogs and cats might not have flourished as they did. With non-avian dinosaurs extinct, predators were free to hunt, reproduce, and diversify. Many species became apex predators and keystone species in their respective ecosystems. Some chose to hunt by ambush, hiding among tree canopies and thickets, while others chased prey across open forests and plains, similar to large African cats. Although not as common as ungulates or carnivores, other important species could be found hanging in trees. According to some fossil records, the earliest known primates appeared in the primitive tropical forests of the Paleogene period. These unique animals likely spent their time in the forest canopy, enjoying the rich diversity of fruits and insects. Over millions of years, early primates developed important evolutionary traits, such as grasping hands, forward-facing eyes, and larger brains. All are characteristics of modern primates. Just a few million years after the great dinosaur extinction, the age of mammals was progressing well, forcing the remaining avian dinosaurs to change and adapt. A common misconception is that all dinosaur relatives were wiped out in the Cretaceous-Paleogene extinction event. It is true that all non-avian dinosaurs were eliminated, but some of their small flying relatives survived. These creatures later became what we call birds, first appearing in the Jurassic period about 150 million years ago. A typical representative is Archaeopteryx, which had teeth and a tail like dinosaurs, along with bird features such as wings, feathers, and a wishbone. Thanks to their mobility and adaptability, avian dinosaurs survived into the Paleogene period and filled empty niches in tropical ecosystems around the equator. Most of these surviving birds were small and agile flyers. They darted between tree branches, hunting flying insects or eating fruit. As these birds spread to new ecosystems, they diversified into hundreds of families and thousands of species. The recovery of terrestrial plants and animals, such as mammals and birds, took several million years. But according to the fossil record, marine ecosystems recovered much faster. Among the organisms most affected by the Cretaceous-Paleogene extinction event were tiny marine organisms called phytoplankton. During the impact event's deadly winter, when darkness shrouded the surface, phytoplankton could not produce energy, resulting in significant declines in some groups. These microscopic organisms are the foundation of many underwater food chains. When their numbers plummeted, a ripple effect spread throughout the oceans, causing many marine animals to disappear entirely. Once abundant creatures like ammonites suddenly went extinct, along with many famous marine reptiles. Aquatic giants like mosasaurs and plesiosaurs simply could not survive in this new world and vanished from the fossil record about 66 million years ago. These marine reptiles would never return, but as the planet gradually warmed and marine ecosystems eventually revived. Phytoplankton populations steadily increased, and food webs formed around new flora and fauna. Some of the first flowering angiosperms developed. They were called seagrasses and over time created lush seagrass meadows, providing food and shelter for many animals. In these flourishing ecosystems, ray-finned fish like ellets became particularly successful. Ellets are powerful swimmers, using their long bodies and forked tails to generate explosive speed and even leap out of the water. As prey numbers increased, predators like sharks also evolved and diversified. Many shark species filled the niches left by marine reptiles, becoming top predators in their food chains. But sharks faced fierce competition from some unexpected rivals. About 50 million years ago, some land-dwelling animals gradually transitioned from a terrestrial to an aquatic lifestyle. These animals underwent significant anatomical changes over millions of years to make the transition from land to sea. Instead of flexible limbs and toed feet, they evolved streamlined bodies, paddle-like forelimbs, and tail flukes. Some of the first aquatic mammals may have been ancestors of modern species like manatees and dolphins. Before swimming easily underwater, marine mammals evolved from terrestrial even-toed ungulates and gradually adapted to an amphibious lifestyle. One of the earliest was Ambulocetus, also known as the walking whale. Ambulocetus was likely semi-aquatic, giving birth on land while hunting in water. It could swim by undulating its long body, similar to modern otters and crocodiles. Although related to some of the largest mammals ever, Ambulocetus was initially only about the size of a sea lion and spent much of its life along the water's edge. As mammals gradually transitioned between land and sea, our planet underwent another dramatic climate transformation. About 56 million years ago, a large amount of carbon was released into the atmosphere, raising global temperatures by about 5 to 8 degrees Celsius. This warming period, called the Paleocene-Eocene thermal maximum or PETM, was likely caused by a combination of natural factors. This geological activity likely released large amounts of methane hydrate from beneath the ocean floor. Simultaneously, volcanic eruptions in the North Atlantic may have pumped CO2 into the atmosphere. Together, these greenhouse gases increased global warming over about 200,000 years and triggered a wave of ecological change. As temperatures rose, expanding tropics caused an evolutionary explosion among plants and animals. Although beneficial for some animals, not all species could tolerate the warmer conditions around the equator. Many animals migrated to higher latitudes and altitudes, such as in present-day North America. Carnivores, primates, and even toed ungulates invaded these cooler environments, where they evolved larger bodies and thicker fur. Many birds also migrated toward the poles, finding areas with less competition and more resources. As these populations migrated and mixed, ancestral species evolved into countless new lineages, many of which still exist today. Throughout geological time, a single event can have lasting consequences, affecting the evolution of species and ecosystems worldwide. Events like the Cretaceous-Paleogene extinction or the Paleocene-Eocene thermal maximum destroyed environments and devastated populations. However, they also created opportunities, driving new players to shape the future of life on the blue planet. Without these events, modern birds, mammals, and flowering plants might not exist or look as they do today. Animals like non-avian dinosaurs may have gone extinct, but their disappearance paved the way for an entirely new living world. And what do you think will happen to Earth after the human era ends? Please leave your opinion in the comments section.
Curious? Subscribe and step through the next anomaly.